Today we are going to learn Chapter 10, Application of Differentiation. There are two subtopics in Chapter 10, which is Extremum Problem and Rate of Change. So first we go to 10.1 Extremum Problem. There are 5 steps to solve the extremum problem. So step 1 is you have to differentiate. Step 2 is find critical or stationary number. Step 3 is find critical or stationary point. And step 4 is use first derivative test or second derivative test. And step 5 is the conclusion. First, we go to the example. Find the critical point on curve fx is equal to x cubed minus 3x plus 2. Hence, determine the nature of that point. Find the interval on which the function is increasing and decreasing. Step 1 is you have to differentiate the function. So the derivative of y with respect to x, you will get 3x squared minus 3. And then the second step is you have to find the critical or stationary number in which dy dx is equal to 0. So 3x squared minus 3 is equals to 0. 3x squared is equals to 3. And then x squared is equals to 1. And then x is equals to plus minus 1. Okay, next, step 3, you have to find the critical point. So in order to find the critical point, you have to find the critical value. So you need to substitute x equals to plus 1 into the function fx. So you will get 0, and then when x equals to negative 1, so f negative 1 is equals to 4. So the critical point is 1, 0 and negative 1, 4. Okay, so for part A, you need to find the nature of the point that we got in step 3. You can use either first derivative test or second derivative test, but first I will show how to use first derivative test. So you need to draw a table and then put the interval, the value of x, dy dx, and then the last one is conclusion. So first we go to the interval, we put negative infinity to negative 1. And then negative 1 to 1 and 1 to infinity. So the value of x, you can put the value in the interval, which is negative 10, 0 and 10. And then when x equals to negative 10, the dy dx will get positive, and then negative 10 for positive. And then when positive, it is increasing, and then decreasing, and then increasing. So we put the conclusion. Okay, so when increasing and decreasing, we got maximum. When decreasing and increasing, we got minimum. So the conclusion is, we got the maximum point is negative 1, 4, and the minimum point is 1, 0. Okay, now I will show you the second method, which is we will use second derivative test. So you need to differentiate again the dy dx. So you will get d square y dx square is equals to 6x. And then when x equals to 1, you will get d square y dx square is equals to 6 times 1, which is we get 6. And then so it is greater than 0. So it is relative minimum. And then when x equals to negative 1, you will get negative 6, which is less than 0. So it is relative maximum. So the conclusion is you will get same as the first method, which is maximum point negative 1, 4 and minimum point is 1, 0. For part B, you need to find the interval on which the function is increasing and decreasing. So we can use the first derivative test that we already got in step 4. So here you can see the function is increasing on the interval negative infinity to negative 1 and 1 to infinity. And the function is decreasing on interval -1 to 1. So just put the conclusion here. And here is the tips. You can use first derivative test to find the extremum point and to find whether the interval is increasing and decreasing. And for second derivative test is you can only find the extremum point.